Welcome to your Classifying Matter podcast. We're going to look at these pictures here and try and sort different types of matter into different categories. All right, let's get started. First type of matter that we have atoms and we have molecules. Every type of matter will fit into one of these two categories. An atom is a single unit of matter all by itself, and a molecule has multiple atoms bonded together. Now the pictures here are going to be increasingly important because you're going to need to draw different pictures of different types of matter and recognize from the pictures that these are atoms. So you can see here the big difference is, are they connected? These are connected together, which means they're bonded. Okay? In the picture, if they're touching one another, they're bonded. If they're not touching one another, they're not connected. These are single atoms. Atoms are single. Molecules have more than one atom. We can also have elements and compounds. Elements are found in our periodic table, right? In the periodic table of elements. Something that might be a little bit tricky though is an element can be an atom or a molecule made up of a single type of atom. Single type is really our qualifier there. So let's look over here. Again, using pictures. I have a single atom of hydrogen. That's an element. An atom of oxygen. That's an element. It's on the periodic table. Carbon, a single atom of carbon. Here, if I use my oxygen, I have O3. 3 oxygens bonded together. Okay? Each one of these is an oxygen. This is still made up of a single type of atom. They're all made up of oxygen. So even though this is 3 oxygens together, it's a molecule because they're bonded, it can still be considered an element. O3. This is the molecule ozone if you're interested. Not testing you over that, but that's what it is, O3. So this is an element. A compound has to be a molecule. It can only be a molecule. And it's made up of 2 or more different types of atoms. So elements have a single type. They can be bonded or not bonded. Compounds have 2 or more different types bonded together. So using the same key I have up here, I can have a picture, and this is a carbon and an oxygen bonded together. That is a molecule and a compound. Okay? It's a compound, 2 different types of atoms. Here I've got a carbon and 2 oxygens bonded together. 2 different types of atoms, compound. This one got 2 hydrogens and an oxygen. Hydrogen and oxygen, compound. And here I have 2 hydrogens and 2 oxygens, also a compound. So if it's all the same type, it's an element. Different types of atoms, you have a compound. I can break them up even further. We're into different categories. I can also break them up by pure substances or mixtures. A pure substance is a substance made up of one type of matter. It can be an element or a compound, as these pictures show to the right. A pure substance has a constant composition. What that means is it only has one type of substance in it. It doesn't matter if it's an element or a compound, but one type of substance. So here, this first picture, I have one type of atom, okay? And they're all bonded together. So let's say this was copper. They look kind of copper colored. I have a lot of copper atoms together, but there is only copper, one type of atom. Down here, I have a box with argon molecules, okay? Also atoms, one atom, and it's argon. A lot of argons, but there is only argon. It can also be a compound. So here I've got a picture of water, and here's the molecular view looking in at the glass of water. This is a compound, H2O, but there is only H2O molecules in this substance. I've got a water molecule here, 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 etc. Because it is only water and nothing else, it is called a pure substance. There is nothing else in there but water. It doesn't matter that it's a compound. It's a pure substance. We would call water a pure compound. And down here I have a block of dry ice. And if we looked really close at dry ice, we could see that dry ice is really solid carbon dioxide, CO2. Notice again in the picture, there are only molecules of CO2. CO2, dry ice, is a pure compound. There's nothing else in there but CO2 molecules. So if it's just one type of substance, an element or a compound, it's a pure substance. But I can also have a mixture. A mixture is a substance made up of multiple types of matter, and it has variable composition. So what does that mean? Well, let's look here. These are three different molecular views of gold, different types of gold that you would see in jewelry. Pure gold, this says 24 karat gold, is only gold atoms, AU. AU stands for gold. There is only gold and nothing else. You can see it is 100% gold. Here, I've got 18 karat gold. And 18 karat gold is a mixture. It's not pure gold. It's not a pure substance. There's a lot of gold in it, but there is also some silver and some copper. Okay? It's not pure. It has different things in it, different substances. And then I can get a lower composition, 14 karat gold. Still has gold in it, but it has more, it's getting to be more silver and more copper. And those are different mixtures of metals that maybe you have some jewelry that is 18 karat or 14 karat gold, and it's not really pure gold. 24 karat gold, as we know, is pure. So the less pure it is, if it's not pure, it's a mixture. Here you can even see a beaker of two different types of atoms in it. They're not touching one another, so they're not bonded, but I've got this solid green type is an atom, and then I've got that smaller kind of hollow gray one. So there's an atom and there's an atom. There are two different substances in the beaker. They're not bonded, so it's a mixture. All right? We've got elements and compounds, atoms and molecules, pure substances and mixtures. One more target, differentiate between homogeneous and heterogeneous mixtures, shows us two different types of mixtures. We're really just getting a lot of definitions out of the way in this podcast. Heterogeneous mixture is a mixture where the particles are not evenly distributed. That will help you out. Hetero, if you know your prefixes from English, hetero is a word that means different. Okay? It is different composition. Let's take a look. We've got this mixture right here, and it has a lot of different types of particles. Down at the bottom I have a bunch of zinc. I have some hydrogen floating around, hydrogen atoms and a hydrogen molecule, a few chlorine atoms, another zinc atom that's not connected to the other ones, and there's really no consistency in this beaker compared to the one down here. This one over here is a homogeneous mixture, or a mixture where the particles are evenly distributed. So let's compare it. If I have, here I have that same picture from the last slide, the green atoms and then the small silver atoms, but they're spread out rather evenly. If I look at this part of the mixture, it looks just about the same as this part of the mixture. There is an even distribution of the particles. Same thing with this box over here. This part of the box looks the same as this part of the box, looks the same as this part of the box, etc. And the box is evenly distributed, all the particles in the box. So it doesn't matter what the mixture is as long as there is more than one type of substance. So in this one, I have an atom. So there's an atom, this red one. And there I have a compound. But it's a mixture of an atom and a compound. This, going back to this first beaker, this is heterogeneous. This bottom part of the beaker looks very different from the top part of the beaker. They're not evenly distributed. So we can differentiate between a homogeneous mixture or a heterogeneous mixture. Again, going with prefixes, homo means same. So the particles have, the distribution is the same throughout. Hetero means different. The distribution of particles is different throughout. A lot of definitions, and here we have a flowchart to help you organize them. How can we break matter down into different substances? Well, you either have a pure substance or you have a mixture. One type of substance or multiple types of substances. If it is a pure substance, it is a compound. And remember, compounds have to be molecules. Or a pure substance, if it is one type of atom, can be an element. And elements can be atoms or molecules. So an example of a compound, we said H2O, right? Has two different types of atoms. And if I wanted to draw a picture, you can see that my atoms, they have different colors, which means they're different substances. So I've got an O and two H's. An element, I can have an atom of chlorine, or I could have a molecule, a diatomic molecule, Cl2. They're both elements. This one's a compound. A heterogeneous mixture just means the particles are not evenly distributed. And a homogeneous mixture means the particles are evenly distributed. All right? Hope you can keep the definitions straight, and we'll look at different pictures and try and match up the terms with the pictures with your practice. If you have any questions, make note of them and bring them in. We'll go over them in class.